So I'd like to start with a little informal poll. How many people have heard of 3D printing? Wow, that follows me around too. It's like the sun. I am the beneficiary of some of the most improbable events. And I only want to start that way so that you know how humble I feel to be here, not only in front of my friends and peers, but as a representative really of a manufacturing, epiphany, a manufacturing revolution. When I graduated from Purdue in 1975 with a mechanical engineering degree, I chose to get into IT because IT was cool. But I can tell you today that manufacturing is cool. And it may have only recently become cool, and it's going to benefit everyone, especially the Midwest that has a tradition in manufacturing, and all the people who have spent their careers putting us where we are. So I don't want to make this a presentation about how smart I am, for God's sakes, but how ascendant a brand new technology is and how important it's going to be for us, our kids, our economy, and I'm just thrilled to be a part of it. Another really exciting part of this improbable sort of collision of events is a partner, the man who put the money in the business, was also successful here in Indianapolis, and I think we should sort of celebrate that. He designed microphones for AT&T. He's basically laid off. He and his two friends sitting around a kitchen table didn't know what the hell they were going to do, and like a lot of entrepreneurs, they just left it all on the field. Within a couple months, they got a big order, and the rest is history. They sold their business, MWM Acoustics, to Harm International for about $50 million, and he basically is all in again. He has a residence in China, but he's born in Greenwood. He lives here in Carmel. He'll be back tonight or tomorrow night. I'm picking him up at the airport. God knows how that's going to work. But those kinds of people are making this a better place to live and a great place to start a business. So there. So my presentation tonight is almost sort of like a book report. In July of last year, Alan asked me for a meeting. He's a customer in my IT business. I said, sure. What do you want to talk about? He said, I want to get you involved in my printing business. And I said, oh my God, not that. My dad owned a printing business. His dad started it. And I said, oh my God, no, don't do that. And thank God I couldn't get a word in edgewise. He was so excited. I found out that it was about 3D printing. But really, what I've learned in the last year and change is what you're going to learn, hopefully, some of tonight. And I couldn't be more excited about it. So please don't ask me about 3D printed guns. Every person I went to talk to says, well, can you print a gun? I say, well, you can, but the person most likely to be hurt will be the person pulling the trigger. These are toys, and you shouldn't play with explosives and toys. It is out there. You can go Google it, but it's far more impressive if you want to learn about 3D printing to go to TED. You probably know about TED. Lisa, I think Haroni does what, as far as I'm concerned, is the very best presentation on 3D printing. You'll go there after you hear me screw this up and really learn about it. Or this. So I'm sitting next to Turner Woodard, who owns the Stutz building. His father was a patent attorney and collected cars, or he did, and he says, geez, you can make parts. I go, yeah. He says, well, can you make parts for my old cars? I go, yes, I can. And I didn't tell him that it cost $20,000. So don't ask me about that. So yeah, unless you have a lot of money. This technology is not new, and that's something that's fun to tell people about. It's been around for a long time. It's 30 years. And we are inheriting all this work that's been done, and we're obviously trying to make money at it. And one of the really kind of interesting things that's happening is a lot of the patents are expiring. So we're seeing incredible innovation now. Not like we didn't have innovation before, but now it's unhindered. So this gadget up here is like a third or fourth generation of what they call fused deposition modeling. It's essentially like a glue gun on a carriage. And it's squeezing out hot goo. It happens to be PLA or ABS. And there's open source technology out there. You know what I mean? Anybody hear of Linux? So I made a pretty good living making Linux stuff. And it's all free, and you can download this stuff. You can make your own. A couple $1,000s for this, but you can probably buy parts for $600 or $800. And if you're clever, and that's what has always, sort of been at the foundation of progress. If you're clever, I think you can get on board and learn about this stuff and have one of your own, and I'll help. So one of the unfortunate realities of 3D printing is it's slow, and I made this up because it occurred to me that it's like using a push-behind mower to cut the grass on a soccer field. These things that are made at almost the microscopic level. We're making a beam, in the case of laser, about 30 microns wide. You know how wide that is? It's about that wide. So it's very narrow, and we have to go over and over and over again. So one of the sort of dirty little secrets of 3D printing is it's pretty slow. And as you'll see that up here we're printing money. Any of the VCs in the crowd? This is the way you really print money. You'll see that one of the disadvantages, there's a lot of advantages, but one of the disadvantages, I thought I'd start with those, is that it's pretty slow, about 4 millimeters an hour to make stuff. You can use all kinds of materials. There's some back there, 130, 40 different plastic materials on that one machine that we have. Lots of different kinds of steels, nickel, chrome, titanium. The aerospace industry is really interested. Medical device manufacturers are excited. You can almost turn your ideas, you can turn your dreams into parts now, which is really cool. Now it comes with some caveats. Got to learn new rules. These new tools have new rules. So you got to get with that program, and there's going to be a lot of learning that is required. Our kids need to learn this stuff at a far earlier age than college. I remember 40 years ago when I was teaching kids how to use word processors. Remember what those were? So we need to get them to think about 3D modeling. And the cost of the machines, somewhat problematic. When I'm trying to sell my stuff for $150 an hour and somebody says, well, I can buy a 3D printer for $300. Well, not exactly the same thing. Hopefully we'll get a chance to talk about that. Precision is what is probably new and most important. This gadget on the right, you might not recognize it because it's inside jet engines, is being built by General Electric. They just bought the largest operator of 3D printing equipment in the world, a company called Morris Technologies. You'll see a high-pressure turbine blade back there. And they bought them for the intellectual property and their machine inventory and their know-how. But that's a jet engine fuel nozzle. And what was an assembly of a lot of different parts, this is one of the takeaways for 3D printing, what was an assembly of a lot of different parts can now be just formed as a single unit. What the Boeing engineers told me when I talked to a guy who's pretty familiar with aircraft applications at the University of Louisville, which by the way is like a world center for additive manufacturing, just down the street, is that the quality control and inventory implications alone are enough to justify this technology. You don't have to make as many different parts, you don't have to measure them, you don't have to keep them in stock, you don't have to assemble them and measure them again and have QC guys floating around like lights on a bug or bugs on a light. So there's a lot of real positive impacts aside from the geometry, which I think everyone agrees is pretty cool. And that, I wish we would have brought that Yoda thing, Eric, because every engineer's dream is to be able to print a Yoda head. I don't know why, but we've got several of them actually. So big names to watch. I think it's important for those of you, and I've done this kinds of presentations before, to know who the big movers and shakers are. Have you heard of Stratasys? That's Brian here is from CATI. He's my very best friend in the category of salesman. He sold us about $300,000 worth of stuff, so you can be you getting him to hook you up for a beer later, and he has probably one of the most interesting stories to tell about 12 years in this business. So despite the fact that he looks like he's 25, you're welcome. And I'm going to order another machine from you, and you owe me more for that. But what a wild ride this has been. To begin with stuff that could barely make parts that sort of fell apart, frankly, that could not be functional in the way that we think of rapid prototyping. In fact, I've coined a new term, rapid iteration, the way that they can today. We're making parts that are going into things and being used. And that's sort of a revolution. It's not just for prototypes and marketing guys anymore. Stratasys, 3D systems, there's just an enormous amount of technology. I put Dassault Systems, Dassault I think is pronounced Dassault, because as I mentioned before, there's a lot of learning that's going to have to come along with this revolution. And where that learning is going to be focused is in engineering. And the way we design things is in this new actually not brand new, but it's a relatively new technology called 3D modeling. In fact, you'll get your hand slapped if you call it like drawings anymore. You know, I can't go show up at a meeting and call it drawings as much as I'd like to. They're models, three-dimensional models. That way of thinking, can you imagine drawing something and having depth in the screen? That's pretty new. I mean, we think of AutoCAD, probably people have heard of AutoCAD. It's so 90s. You know, we have to think about a new way of representing objects which have depth. And I think it's fair to say that SolidWorks, which is a product that we use from Dassault Systems, is probably one. Shapeways, who's ever heard of Shapeways? How cool is that? It's like a 3D fulfillment service. You know, UPS is putting 3D printers in their print stores. I think, not Staples, but one of the other Office Max or some of those guys are putting 3D printers. I think it's pretty hard. I don't know if they'll be successful, but Shapeways has pioneered a model where you upload your model and like $40 later, they just ship it to you. Now, it doesn't always work because the quality of the model is still going through a process of innovation and improvement. But Shapeways will turn your ideas and your models into parts that they'll ship to you. And so it's like a scratch your own itch thing. Thingiverse, anybody here a Thingiverse? Crazy. My granddaughter and I sit at our table and that MakerBot back there, which if you haven't seen, you should, probably one of the first or second generations of consumer 3D printers, you can just print stuff. So she's 10 years old, she gets out my laptop, she says, what do you want to make, Poppy? I said, well, let's go make a peace sign. Downloads a peace sign from Thingiverse, an STL file, that's a new vocabulary word that you ought to pick up, and she prints it on the MakerBot. She takes it to school. This sort of scratch your own itch, you know, iteration. Software people have been able to do this for like how long, ever? I've been in the software business for close to 40 years, and what do software people do? They write some code and they throw it up on the screen or on the web or where have you, and it doesn't work, right? It never works. And so you fix it, you iterate, you make new builds, right? Well, compared to the manufacturers, who I now call the adults in the room, software guys are weenies. When we make mistakes in steel. And so I don't know how I got on that subject. I just wanted to get my rap on software guys. And rep, or this is actually called a Hadron Ord bot, I think. You know, the pride of ownership, you get to name it anything you want. So we could talk about what sort of impacts 3D printing will make for the next few hours. Somebody says, well, what's your target audience? I have no freaking idea. The fact is that it could be any of these. Rapid iteration. It's like the software, but you now get to make new parts every morning instead of new builds of software. Risk mitigation. We're making parts for Black & Decker, gasket something. They want to find out in the first 10% of the product life cycle if something's going to break instead of the last 10% after they've paid for tooling and product testing and packaging and engineering that they can't claw back. So that's a big aspect of 3D printing. Lot size 1. Wouldn't it be cool to like they have done now in publishing to just like print a book to make a part? And you can apply this to biomed where your knee, your left one, your right one, parts of your body are so unique that you can now just make one of something and not have to suffer the expense of the investment in all of that infrastructure that it gets to take to just make one. This biomimicry term, I hope that you're listening because that's going to be the next big thing. Making parts the way nature makes parts. You know, if you were made of solid bone, you wouldn't have been able to make it up the elevator because you wouldn't have been able to get out of bed. You would have weighed too much. And so the old way of making things, which is what I call dumb steel, see, solid steel, is going to be replaced with the new way of making things, which is this fibrous, tendon-like material that has like honeycomb shapes like nature makes. Making stuff from the inside out, that's the new way of making things. Part consolidation, I've already mentioned. Education, we hope to move a few of these 3D printers like that into schools. We've already got a program going on with the library. I'll maybe talk about it a little bit later. Art and jewelry on Shapeways is the dominant. You can just have a gadget that you made up that maybe has your name, or as I mentioned before, cake toppers with your face and body parts on. So you can use this 3D printing stuff for so many different aspects of both commercial and industrial and educational. It's hard really to focus. Of course, Paul will tell you that I've never had a problem with focusing. So I'm not going to bore you with pie charts. This is not death by PowerPoint. If you want the slides, I'm sure that someone at Techpoint will be glad to give those to you. But it's being distributed all over the place. It's all over the world. U.S. is not leading in this technology. The Objet printer that I've got was designed in Israel. The EOS metal printer that I've got was designed and shipped from Germany. There is one dominant player in the U.S., I think X1. They're making big parts, about $1.5 million. There's an example. I mean, you have a problem with your jaw. Get to a fight in a bar and somebody knocks your jaw off. I don't know if that actually would happen, but they can make a new one. We actually got an inquiry the other day that I happen to know is playing out in Europe and in Asia really well. They're making crowns and bridge work on an EOS printer in nickel chrome. The dentist would scan your jaw, your tooth, and there's this one company I happen to know in Shanghai that's making like 500 a day. Talk about printing money. There's a video on our website. I don't know if you can see that. It's called Magic Arms. It was made with a Stratasys printer. I get kind of choked up. This girl has a genetic problem that her bones don't grow. And so in order to give her the ability to move her limbs, they make this superstructure that wraps around. And the problem, of course, kids grow. It sucks. And what they can do with 3D printing is constantly make new parts for her. It's really amazing. This is what I'm talking about when I talk about the new way that things will be made. When you started in the past with a chunk of steel and you whittled away at it, what choices did you have? When you started with a mold and you poured steel into it, what were your options? Well, with this new way of doing things, you've got some options. I can make stuff the way that birds make wings. I can put metal in places where you can just define by whatever the resolution of your modeling software is. And so that's going to start to dominate. They're using this part actually in an airframe. It's taken pounds out of jets. It's hundreds of pounds out of overall for airframes. So it's going to change the way that things are built. Oh, but does anyone notice the dress? This is a 3D printed dress. That's the only reason I put it up there. So I wouldn't want you to leave without knowing the sort of proper nouns. We're calling it 3D printing, but I think if you had like an arm wrestling contest with somebody who knows, they would prefer that you call it additive manufacturing. Now, the people who practice the old way of doing things, and of course, they don't know that it's the old way of doing things, they just think it's the way of doing things, are now sort of relegated to the subtractive manufacturing paradigm. So I'd like to have you think of this as sort of a teeter-totter here. In the old way, we used to whittle away material. The material, the steel, the chunk of metal, whatever it was just about free. I mean, practically speaking, it was about free. But you paid enormously, and that's another famous Indiana company, Herco. You paid an awful lot of money to whittle away the shape. Well, today, I can give you any shape you want. But I actually pay for about every molecule. And that's an enormous difference in the way you design things. Again, organic or biomimicry versus this old subtractive way of doing things. They are lot size dependent. I could care less. As I mentioned, it's sort of slow in the 3D world. And the old way was designing for fabrication. We actually had to figure out, as we were designing how something was going to work, how we were going to make it. It was a real priority because I'd hand it to an engineer like Eric and he would throw up. He'd say, you could draw, but I can't make it. Today, I can just about make anything you can design. And now you can form the most important aspect of the design on your functional performance. Of course, I couldn't talk to a Techpoint outfit without showing you the normal hockey stick growth curve. The truth is that's not us. This is actually snagged from a famous annual report on the 3D printing business. And again, Alan's put in about $1.5 million. We found it this year. We did get $700,000 in IEDC, and I tell my libertarian friends it's all paid on the back end. So I'm not offending my roots. We did get some killer press in the IBJ. This community has been such cheerleaders for us. It's really been amazing. The factory where we live has been given to us. It's a donation from Bill Witchger, a famous, maybe not famous, but certainly well-recognized philanthropist in Indianapolis. Maybe we'll have a sales. When would you ever see a sales forecast that was like true? Maybe we'll have sales of about $100,000. We're waiting for a couple big orders, and some of them are like right there. I mean, we're waiting on a big order from Brit Aero, which is a major aerospace manufacturing company here. Got a good relationship started with Rolls-Royce. We've done some parts for Lilly. Like I said, there's a part back there from Zip Speed Weaponry, the bike guys. We've really gotten some traction. It's really been fun. Those are our two machines. You don't need to see those. I think I can show you a very short video of how the steel printing stuff works. So before you see this, I'll set it up. So we start with steel powder. It looks like flour, about 15 to 40 micron diameter, little specks of it. Almost floats in the air. And we lay it on a bed about 20 microns thick on a big hunk of steel, and then we fire lasers at it. And essentially what's happening is we're melting the lasers at the focus of, we're melting the steel at the focus of that laser. And that's what you're going to see here. You're going to see this laser dancing around on the steel powder. That's making a herringbone gear, which would be pretty hard to make otherwise. But like I say, we don't care about shapes. So for the long version, you have to go to the YouTube. So I'm about wrapped up. I just wanted to talk a little bit about where we are as a culture. As I've mentioned already, 3D modeling, big deal for kids. I mean, what every kid should have on their laptop, if they still have laptops, would be SketchUp. It's free. And download it. It used to be a Google product. Now I think it's from Trimble. And you can do an amazing amount of work with it. You can design things. You can give them shapes. And if you are able to, you can then turn that model into a product. You can send them to Shapeways. 30, 40 bucks, I would say, would be kind of a typical cost to turn this smallish gadget into plastic. Send them to us. I mean, we'll work with it. Or I think under every Christmas tree, I mean, any Jewish people here? Whatever you celebrate this holiday season should be a 3D printer. I remember, and you don't have to buy it from me, but I remember when computers were, anyone else remember when PCs were $4,000? Mm-hmm. Yeah. I remember back in the day when they were $4,000 and I sold them and made 40 points. Now that's pretty dramatic. They're just very old. So it's well within the possibility that students today can and should begin understanding how modeling works and what to do with that creative energy and that, well, like Malcolm Gladwell said in The Outliers, be invested in those 10,000 hours that they can spend between grade school and college. And of course, as I've also mentioned, the intellectual property concern, I hadn't mentioned that, and with Paul here, I would defer to him. There's a real concern because now I can take the scanners that JD is offering. JD's out there somewhere. There's JD. He can scan something. He can reverse engineer it. He can make another one of these things. And that really represents some kinds of issues that we're going to have to deal with as a culture too. But what I began to say is, I mentioned before, this manufacturing adoption. It's a long life cycle. Some parts last a long time. And we have to get to the engineers early so that they make more things that look like this than like this. And I think that that's what we can do. I think what we will do. And I know that here in the heartland, we'll lead the rest of the nation. So that, I think, takes me to my last slide.